Hello, welcome to Maths with EJD. In this video, I'll be talking about the Hungarian method solution to a matchmaking assignment problem. In the two previous videos, I talked about a Hungarian method for solving assignment problems generally, where we mentioned that in an assignment problem, you have two groups of equal number that you're matching uniquely to one another. And then we saw the Hungarian method for taking care of that. So in another video, I talked about how to use that to solve a project assignment problem where we assign uh, four different projects to four different contractors. Of course, the deal is each contractor gets a unique project, and each unique project is assigned to a unique contractor. So in this case, I'm thinking of the fact that matchmaking is also like an assignment problem where you match a man to a woman and things like that. So every man is matched to a woman and every woman is matched to a man like that. So I feel we should consider that kind of situation. So in this case, we have three men, three women, and we now have something like a disadvantage index, so to speak. We have a disadvantage index to measure the level of disadvantage between a particular man and a particular woman. And then our deal is to find the minimum disadvantage we should assign each man to each woman in such a way that the disadvantage index is minimized. So we can have the disadvantage index matrix like this. Okay, so the three men are Dosa, Sewanu, and Huenu, right? Whereas the three women are Medese, Bendo, and Dona. Okay. So so for the disadvantage indices between Dosa and Medese, it's minus 25. Between Dosa and Bendo, it's minus 27. Between Dosa and Dona, it's minus 22. Between Sewanu and Medese, it is minus 19. Between Sewanu and Bendo, it's minus 18. Between Sewanu and Dona, it is minus 17. Then between Huinu and Medese, it's minus 24. Between Huinu and Bendo, the disadvantage index is minus 22. And between Huinu and Dona, the disadvantage index is minus 20. So we have this. So our goal is to assign each man, want to assign each man to to a woman, assign each man to a woman in such a way, in such a way that the in such a way that the disadvantage index is minimized. And the disadvantage index is minimized. That's our goal. Okay. That's the usual assignment problem thing. So let's go for that. Um, so let's say we have the solution next, and we start out with the matrix itself. So we have the disadvantage matrix, index matrix, minus 27, minus 25, minus 27, minus 22, minus 19, minus 18, minus 17, minus 24, minus 22, and minus 20, like this. So the first step we want to do is so first we talk about the row minimum subtraction. Row minimum, so row minimum subtraction. So what that simply means is that we identify the minimum value in each row. So in the first row here, it's minus 27. In the second row, it is minus 19, I believe. In the last row, it is minus 24. Minus 24 is the least in the third row. Okay. So to do this now, we move on to, so we then deal with that. We have, so in the first row, definitely we have minus 25 minus 27. Okay. Next row, we have minus 27 minus minus 27. And we have minus 22 minus 27, like that. Then we have, for this now, we have minus 19 minus 19. Next, we have minus 18, minus 18 minus 19. Then minus 17 minus 19. Then we have minus 24 minus 24. Next, we have minus 22 minus 24. Then minus 20 minus 24 also. So we have all this, and that translates to, okay, let me just take it step by step. That's like minus 25 plus 27, minus 27 plus 27, minus 22 plus 27. Next, we have minus 19 plus 19. Next, minus 18 plus 19. Next, minus 17 plus 19. And lastly, we have minus 24 plus 24. Then we have minus 22 plus 24. And we have minus 20 plus 24. So I didn't have to do all this, but I just feel I should take the pain. So minus 25 plus 27 is 2. Minus 27 plus 27 is 0. Minus 22 plus 27 is 5. Then minus 19 plus 19 is 0. Minus 30 plus 19 is 1. Minus 17 plus 19 is 2. Minus 24 plus 24 is 0. Minus 20 plus 24 is 2. Minus 20 plus 24 is actually 4. Okay? So that is the, so we have 20501 2024 for the first step. The first step is the row minimum subtraction. So now we move on to the next step where we do the column minimum subtraction, column minimum subtraction. Okay. What that means is that we look through the columns now. What we did with the rows, we do with the columns. We look through the columns now and check and take notes of the minimum values in the columns. So in column 1, 0 and 0 are minimum. So those are the smallest. In column 2, 0 is the minimum. In column 3, 2 is the minimum. So in that case, then we just go ahead and say that we have 2 minus 0, 0 minus 0, 0 minus 0 there. Then here 0 minus 0, 0 minus, 1 minus 0, 2 minus 0. And here we have 5 minus 2, 2 minus 2, 4 minus 2, like that. And then that leads us to 2 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 is 0, 1 minus 0, 1, 2 minus 0, 2. Then for the last column, we have 5 minus 2, 3, 2 minus 2 is 0, 4 minus 2 is 2. Now, the next thing we want to do is to check for optimality. So that's step 3 now. This is step 2 so far. So step 3, we check for check optimality. And how do we do optimality? We cover all the zeros with the minimum numbers with the minimum number of lines we can actually do. So we have 2, 0, 3, 0, 1, 0, 2, 1, 2, 0, 3, 0, 1, 0, and then 0, 2, 2, like this. So what are the possibilities we have? We can cross this out 1, we can cross this out 2 and 3. Do we have a better way of doing that? We can actually do the row thing. We can cross this out, this and this. That's also 2. Is there a way we can actually cross them out with less than 3 lines? It doesn't look like that's possible. Okay. So whether you use vertical lines, it's 3. If you use horizontal lines, it's 3. And there's no way we can actually, if we can't even combine both. Okay. We can't combine both. So the minimum number of lines we can use is actually 3. So in this case, so to check optimality, right, you see you have 3 lines. That's the minimum number of lines you can use. 3 lines, and that is equal to number of, so here we have 3 rows and 3 columns. So you have 3 men and 3 women. So 3 lines is equal to number of rows, which is also like the same thing as number of columns. So what that means is that since the number of lines, minimum number of lines you can get is equal to the equal to the number of rows or columns, then we can say optimality has been reached. Optimality has been reached. If the lines are not the minimum number of lines is not equal to number of rows and columns, then optimality has not been reached. So optimality has been reached. So the next thing we then have to do is get to obtain optimal solution. So that's the next step now. For obtain optimal solution. Obtain optimal solution. So in that case, we write out what we currently have. That is two. Okay, well, we bring the original situation, right? Um, you go back to what you started with. Dosa and Huenu are the men. We have Dosa Sewanu and Huenu. Okay. Dosa Sewanu and Huenu. Okay. And then for the women, we have Medese Kwendo and Dona. Medese Kwendo and Dona. Of course, this is 203, and this is 010, and this is 022. So this is Medese Kwendo and Dona. So are the three women. So, and this is the matrix we have, right? So how do we, since this is optimal solution, so we have to definitely find a way of doing the matching. Each man has to get a woman, and no man gets more than one woman, and no woman gets more than one man, and no man gets, like the matching has to be uniquely done. So of course, for Dosa, right, the only option available to Dosa is Pendo, right? So we are going to have that assignment. Then when we go to Sewanu has the option of going for Medese and Dona, but the trouble is that Huenu only has the option of Medise. So automatically, Sewanu cannot get Medise anymore. So automatically, Sewanu has to go for Dona. So at the end of the day, we have our optimal matching. Okay, we have our optimal solution. So we can say, therefore, the optimal solution is obtained with the following matching, with the following matchmaking, with the following matchmaking. Okay. The first one is, so you assign Dosa. So assign Dosa to Pendo, and we also have to take cognizance of the disadvantage index. The disadvantage index between Dosa and Pendo is -27. Okay. Disadvantage index is -27. Of course, the other matching is Sewanu and Dona. That's -17. And the third one is Huenu and Medisa. That's -24. So we have to pay attention to all of that. So match the Satukwendo, right? And you get the disadvantage factor in that case to be -27. Okay, that's -27. Let's do it that way. -27. Then the next matching is Sewanu to Dona, right? So match Sewanu to Dona, and that is the disadvantage index is -17 between Sewanu and Dona. And lastly, you match Huenu and Medese. So Huenu is matched with Medese. So when you match Huenu with Medese, right? The disadvantage index is -24, like we have in the original table. So with this matching now, what's the total disadvantage index? So we have total disadvantage index, total disadvantage index, and that is equal to -27. Okay. See this now. So -27 -17, that's -14. 44, right? Minus 44. Then minus 44 minus 24. That's minus 68. So the total disadvantage index that is optimal is minus 68. So it's minus 68. So what do we do? Now say, therefore, yeah, I mean that's pretty much the result, right? So therefore, by by matching by matching the couples, by matching the couples as indicated, as indicated, we get a minimum disadvantage index, a minimum disadvantage index of minus 68. And that's how that is. If you have not subscribed to this channel, you have already seen that you have a whole lot to learn. Please be sure to sign up right away, subscribe, and then hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know if you want me to teach a topic or if you want me to solve a problem. Then like and share so that more people can have access to this great content. Till I come your way again, have a perfect time. Bye.